In this video, we're going to actually evaluate a double integral. So we have our integrand x squared y. We're going to integrate first with respect to y, which means that these bounds on my integral symbol are 1 to 2. That's y is between 1 and 2. And then dx comes second, so that means my x values are between 0 and 3. So let's think about what this rectangular region or surface looks like. My x values go from 0 to 3. My y values are between 1 and 2. So this is our rectangular region right here. That is R. I'm getting that R from the bounds. And again, since dy is first, this first integral symbol that we're going to evaluate with respect to, that's going to be y. And then we've got dx, my x's are between 0 and 3. And then x squared y, that's my function of two variables. That's f of x, y, or rather, that's my function z. So that's my surface in space. And so that's floating above this region. The region is in the xy plane. And so z is somewhere up in space above the region. So when we do this integral, we're going to be calculating that volume between the surface and this rectangular region in the xy plane. So let's work from the inside out. So integrating in here, we're integrating with respect to y. That means we treat x as a constant. So I still have my integral from 0 to 3. And if I integrate y, that's going to be y squared over 2. So I have 1/2 x squared y squared. And remember, these represent y values, so I'm going to evaluate y from 2 to 1. And then I'm going to integrate again with respect to x. So that 1/2, I'll go ahead and pull that in front. So I've got 1/2, 0 to 3, x squared, y squared. And that needs to be evaluated from y equals 2 to y equals 1 dx. So I'm plugging the 2 and 1 only in for y squared. So 1/2 integral from 0 to 3. If I plug in 2, I'm going to have 4x squared minus, when I plug in 1, I get 1x squared dx. So simplifying what I have in there, we have 3x squared dx. So now I'm going to integrate with respect to x. And the integral of this plus 1 is 3. Divided by the 3, we get x cubed. So I have 1/2 in front, end up with x cubed, and I need to evaluate from x equals 3 to x equals 0. Which is 1/2, 3 cubed is 27, minus 0 cubed is 0. Our final answer is 27 over 2. So there's almost always going to be some algebra simplification in here when we plug those values in. And the other thing I just want to stress, we're not used to writing x equals or y equals, but I encourage you to do that because I think that's really going to help you when you're evaluating to remember where to plug those bounds in. All right, so that's it for this video. Email me if you have any comments, questions, concerns, anything. I'm here. I'm here to help. Have fun and be safe.